once the assignment date is due date is completed, automatically it will stop getting the submission, so we can stick on the dates. So we are going to see the overview of the new chapter. We can call it as a spatial image enhancement. We are discussing the topic called image enhancement. In this, we are going to discuss about two things: spatial domain and frequency domain. Okay, what is meant by image enhancement? Anyone, just we can reply in the chat box. What is meant by image enhancement? I'm giving an example. If you take any one image, black and white image or colorful image, just I'm performing some operation so that the image brightness or contrast or the size of the image or a part of the image is able to change, then we can call it as a image enhancement. So whenever we are performing some operations on the image with respect to the quality, the brightness or contrast, it will be improve the image clarification. It will be improve the image visualization. Then we can call it as the image enhancement. I'm repeating. Whenever there is an image, we are performing some operations. I'm not mentioning any operations. I'm generally telling we are performing some operations on the image, small part of the image or whole part of the image. Then doing with that operations, we're able to improve the quality or improve the vision of the image. Then we can call it as a image enhancement. It can be done. The image enhancement, that is the improvement of the image in terms of brightness, contrast or size or a part of the image or the whole image. It can be done through two different types of domain. One is we can call it as a spatial domain. Another one we can call it as the frequency domain. Okay, spatial domain and frequency domain. So two methods, the two ways we are able to enhance the image visualization. It may be a brightness, contrast, or a part of the image, the whole part of the image. Okay, two types, spatial and frequency domain. We can see one by one. What is the spatial domain and what is meant by frequency domain? Okay, consider this is an image. I'm not mentioning, just you can consider this is an image. This image is converted into the matrix in the MATLAB matrix. I'm using the matrix as 3x3 matrix, that is 9 elements. So this image will represent the form of the matrix. I'll be performing here the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 are nothing but it is a pixel intensity values. It is a pixel intensity values. Intensity values nothing but it is a brightness of an image. Brightness of an image. What is the pixel brightness? They will be representing by the value 1, 2, 3, 4, 5, 6, 7, 8, 9. The value will be ranged from 0 to 255. According to the image, the particular pixel intensity values will be changed. These values can be represented by using the coordinates x, y. That is called row and column. The intersection point, we can have some value. That value can call it as a pixel intensity value. If you are performing any operations, in the pixel by pixel. We are performing any operations in the pixel by pixel by applying a value from outside of the image, applying the value from outside of the image. For example, I am performing the value 10. I want to perform addition in this whole matrix. Then I'm going to change the pixel intensity value. After changing that, I am able to get another matrix where it has some changes in the image. So I'm taking the image, converting the matrix. I'm performing any operations on this pixel intensity value, coordinate by coordinate, value by value for the entire matrix by adding or subtracting or multiplying with a constant number. Then the whole in pixel intensity values are changed. So that value are able to give some image. That image we can call it as a image enhancement. So here the operations are performing in each and every pixel value. So it is called as a spatial domain. So it is called as a spatial domain. We can clearly mentioning that the digital image of Cartesian coordinates of discrete rows and columns at the intersection of each and row column is a pixel. The pixel as the value will call it as the intensity. This pixel is going to perform some operations by a constant value from the outside of this matrix. We can call it as a spatial domain. Okay, we are performing operations on the image by a single value with entire matrix. It is called the spatial domain. The another domain we want to discuss, we can call it as the frequency domain. It uses the scientific mathematical operations to perform the frequency domain. The mathematical operation is the discrete Fourier transform. We are applying a formula called discrete Fourier transform for this matrix so that we are able to get the enhancement in the image. Because if we take any image converted in the matrix, we are performing some operations. That operation will be change the pixel intensity value, so the image will be changed. These changes will be give the improvement in the quality or the vision, that is called the image enhancement. It can be done by performing a single element with all the matrix, or we can able to perform by using a Fourier transform. If we're performing a single element, we can call the spatial domain. If we go in image enhancement with the Fourier transform, it is called as the frequency domain. So here we are going to perform two operations. One is spatial domain, the another one is a frequency domain. Yes. Umang, do you want anything else? This is about the spatial domain and frequency domain. So image enhancement is nothing but we are performing some operations on the pixel intensity values. The operation may be a subtraction, addition, or multiplication, or any other operations in the pixel intensity values to get a new pixel intensity value. That new pixel intensity value we are able to get an image that is called as the image enhancement. Okay, I'm giving an example, simple example in the Octo online. So I'm sharing the Octo online so that you are able to understand what I'm going to tell. I'm opening the Octo online. I'm sharing that Octo online to you. Stop presenting. I hope that you are able to see the shared screen. I'll take some time to display. Yes, it is visible. Now, what I'm going to know, I'm just loading an image. I am A is equal to IMAGA, sorry, I am read of an image. I'm going to use an image called 0.png, close it, semicolon. The image has the values in the matrix. You can able to see the matrix value. Want to see the size of the matrix, size of A. You can see the matrix size is 961 and 860, meaning that 961 rows and 860 columns. Okay, so this much pixel intensity values is available. Now what shall I want to do now? I want to display the image. I am sure of A. You can see what is the image is going to display, what the image you have read, what is the image, the pixel intensity values are shown. Here you can see a bird image is displayed. Okay, here I'm going to perform an operation. Just I'm going to add the value 10 with this matrix. This is a matrix where we're able to see the n number of pixel is available, the number of rows and number of columns is available. We can able to see by using the command size of. We can able to see size of A. So we can able to see there will be a 961 rows and 860 columns. We can able to see the images displayed, a bird image is displayed. Now I want to perform spatial domain. So it can be any one operations. I'm going to make an addition operation. I'm just adding a value 20. Just I'm adding a value 20 to each pixels. Okay. So I'm going to use B is equal to, there is a matrix that is already available in A plus, I want to use A dot plus 20. The dot is used to represent the value 20 to be added in each and every pixel intensity values and created a new matrix. It will be stored in the variable B. Now we can see the value in the B is added with value 20, all the elements is values added. So some changes is done in the image. I want to see what type of changes is done. So I'm going to display original image as well as the after the value added 20 to the image. So I am show of A. I'm just showing original image. I'm showing the original image. Now I'm showing the spatial domain operations variable B. Able to see I'm just added the value 20 with all this image. So you can see about this is any changes is reflection. Yeah, there will be the brightness is improved. You can able to see some brightness is improved. You can see the brightness is improved between these two images. Again, I want to perform some other operation. I'm going to reduce some values. So I'm using C is equal to A is the matrix where the original image is available. So A dot minus 80 semicolon tricky. What happens? The 80 value will be subtracted from the original image. So I'm going to show the original image and I'm going to show the subtraction. After the subtraction of 80 value 80, what is the image? I am sure of C. You can able to see the difference. You can able to see Now the brightness, the contrast is increased. So in this way, the domain, spatial domain is used for the image enhancement. And giving a simple example for how the spatial domain will be affected the image. If you go for the colored image, then you can able to see more types of changes. So from this point, I want to conclude that by adding a single value to the entire image, so it performs some image enhancement will be happen. It will be increasing, it may be increasing the brightness, or it may be increasing the uh, contrast, or it may be increase the visibility of the image. This type of operation we can call it as the spatial domain. This type of operation is called as a spatial domain. Just we are adding a value, with this value perform some operations, the addition, subtraction, whatever may be. Okay, this operation will be done for each and every pixel in the matrix. Go for the frequency domain, we are performing the Fourier transformer. There is a formula converting this matrix into the Fourier transform. Then we are converting this Fourier transform output into the image. We are able to perform image enhancement. So this is about the spatial domain, and this is about the frequency domain. I hope that you are able to clear, because I'm not giving any example for the frequency domain. While we are discussing the frequency domain, I will giving an example. Okay, now we can see some mathematical formula how the spatial domain will be performed. Okay, we already know that f of x, we already know that f of x comma y, function of f of x comma y is equal to pixel intensity value. F of x comma y is equal to pixel intensity value. This function will be give the output as pixel intensity value. How it can be applied? For example, we can consider is the matrix is an image. The image is converted in the matrix. I'm telling that the matrix is a 2 cross 2 matrix. So it is only 4 values. I want to check f of x comma y. So x represent the rows, y represent the columns. You already know that in MATLAB, the index value is starting from 1. So if I want to read this value, 2, so I want to use f of 1 comma 2, where 1 is the x. We can see that row, the first row, the 2 represent the column. In first row, second column. So what is the value? 2. This 2 will be representing the pixel intensity value, brightness of that particular point. If I give f of 2 comma 2, second row, second column, it intersect with the value 4. So it gives a value as 4. 4 is a pixel intensity value. So f of x comma y will be representing the pixel intensity value at the particular coordinates, where x and y will be the rows and columns. If f of x comma y within square bracket, we can put t. T is nothing but an operation, transformation. T is putting the variable called transformation, some operations. So for this entire thing, we are doing some operations. We can call it as a transformation. So this equation will be stored in g of x comma y. G of x comma y. But the g of x comma y will give we're able to get the value of the transformation of the particular pixel. Transformation of the particular pixel. We can see g of x comma y is equal to t of f of x comma y, where f of x comma y will be able to give the pixel intensity values. Then t of f of x comma y give the transformation of this particular pixel intensity values. and will be stored in the function called g of x comma y, where f of x comma y is the input image, where we are giving the original image. By using the t, we are able to perform processed image, so that the processed image will be stored in the variable called g of x comma y. So f of x comma y will be representing the input image. G of x comma y is storing the processed image, where t is an operator. We're able to perform some operations on the neighborhood of the pixel. On the neighborhood of the pixel. If we go for the neighborhood, there is a 4, 8, the diagonal. That is left, right, bottom, top, the diagonal 4 values and 8 values of the pixel. So the T representing the some operations on neighborhood of the pixel. Some operations on neighborhood of the pixel. Okay, this is about the mathematical representation sorry, of an image. The mathematical representation is nothing but it is a formula how to represent the how to represent the processed image and processing image by using the word called T, the transformation. So in this way, the mathematical equation is represented for the spatial domain enhancement. It is only for the spatial domain enhancement. Okay. Up to this, we are going to stop the today's lecture. Tomorrow we can see how this transformation taken place by using the different types of operations. Now I'm requesting everybody just you can share your enrollment number for attendance. I'm requesting everybody just you can share your enrollment number for attendance. Those who are given attendance, we can leave the class. Those who are given attendance, we can leave the class. I'm requesting everybody just you can share your attendance. Kindly share your enrollment number for attendance. Those who are given the attendance, we can leave the class.
Hello.
Yes.
Hello. Excuse me, sir. Sir, I wanted to ask one thing, not
Okay.
related to particular IP, but I just wanted to know that, sir, if I have an idea which is
Okay.
not implemented yet, and I want to write a research paper on it. So what will be the exact procedure? Can you please tell me?
Okay, if you want to write the research article in this image processing means you want to select a specific domain. You are writing in medical field or you are writing in civil field or mechanical field.
हेलो
Yes,
सर सर वो नेटवर्क इशू से कट गया था.
okay, okay, it is audible now.
या सर.
Yeah, if you want to write in research paper in image processing means, I give you an example. For example, in mechanical, if you go for the image processing in mechanical oriented, if you go for the two pipes, they're putting a welding in the pipe. The pipe is able to fix under the water.
ओके सर.
So if you fix under the water, there should be no air bubbles. There should be no holes or airs to be inserted. So while welding, no, after welding, there is a lot of method to check it. So our method is just we can take the image. You want to identify by using your algorithms, is there any space is given while welding?
ओके.
It is one example. The another example you go for the medical means each and every time if you go for the scanning, mostly they're giving an images. If you go for the hot MCR, sorry, MICR scanning, okay. If you go for that, the image are displayed not clearly.
ओके सर.
We want to improve by using some operations where you're studying the image enhancement now, so that we're able to identify the particular nerves or particular valve, so that you can easily identify is there any problem that valve or not.
Okay. So, sir,
So
is there any specific format to write that report?
what format, ma?
I mean, suppose I have an idea and I am not sure, but I have an idea. Okay. So I
Hmm.
want to present it in a research. So is there
Hmm.
any specific format for research paper, writing research paper?
No, depends upon the journal. That format will be differ.
Okay.
Just you want to write the content. Okay, the format is there is a 5 divisions for writing the paper. The first part you want to write about your abstract. The second part you want to write about your work, related work, what you are going to tell, introduction of your work. The third part you want to tell about the literature survey, how you are identify your problem.
Okay.
The fourth part will be your problem, how to solve the problem by using your technique. The techniques, algorithms, everything will be there. The fifth part will be the comparison and conclusion. How you are getting the result, then the
Okay.
result, then the conclusion part.
Okay. So, sir, where can we submit our research paper, like IEEE or something like places?
Yeah, for this, there is a n number of journals is available.
Okay.
Okay, you want to search the journal in such a way that the scope of the journal should be coming under our domain.
Okay.
So each journal we are having in some scopes. Scope means in which area the journal is working.
Okay.
So in this we want to search, we want to see that there is a image processing is there.
Okay, sir.
Okay, this is the method how you want to post.
Yes,
Is it
sir. Yes,
clear?
sir. Thank you. Yes, sir.
Yeah,
Thank you so
fine.
much, sir.
Okay, okay, fine. Yes, Jeet, have you given the enrollment for attendance now? We can leave the class.